This is a MOSFET, and inside there's just a tiny piece of semiconductor. But these components are so important and we find them everywhere. MOSFETs look something like this. They come in many shapes and sizes. They are represented with symbols like these in engineering drawings. I'll explain those later in the video. MOSFETs have 3 pin terminals, and we call them the gate, drain, and source. Sometimes these terminals are in a different order, but we can check that on the manufacturer's datasheet, and you can find that online using the part number which is printed on the front of the component. I want you to imagine water flowing through a pipe. We can block the flow with a disc. There is a hole in one side of the disc, so if we slide the disc across, we can let water flow again. The disc is spring-loaded, and so it is normally closed. Another pipe connects to this disc, and the pipe is filled with water. If a small pressure is applied to this pipe, it won't be enough to move the heavy disc. But at a certain pressure, the disc will begin to move and allow the water to flow. As we increase the pressure, the disc fully slides across and the water can fully flow. But if we remove the pressure, the gate closes and the flow of water stops. This is basically how the MOSFET works. If we take a lamp and we connect it to a power supply, it will turn on. If we insert a switch, we can manually control this. If we insert a MOSFET between the drain and source pins, the lamp will remain off until we apply a voltage to the gate pin. And that means we can use a controller or sensor to turn the lamp on automatically. But if we vary the voltage on the gate pin, we can vary the current flowing through the main circuit. And that means we can also dim the lamp as well as turning it on and off automatically. Instead of a lamp, we could control a relay, and the relay can control an AC circuit. And that means we can turn an appliance on and off automatically and even remotely. We could also control the speed of a DC motor. The motor can rotate forwards or backwards depending on how we connect the power supply. But using MOSFETs, we can automate and change the direction. Some electrical loads have a high current, which causes the MOSFET to heat up. So we attach a heatsink, which increases the surface area with the air and helps to cool it down. For example, this DC power supply uses MOSFETs. The MOSFETs are attached to some very large heatsinks. Without them, they quickly rise in temperature. We can turn MOSFETs on and off extremely fast by using a pulse width modulation signal. That lets us efficiently control the brightness of an LED light. We have an entire tutorial on how to design and build that circuit, links down below for that. Okay, but why can't we just use a transistor? Well, a BJT transistor requires current to be applied to the base pin, and that wastes energy. A MOSFET only needs voltage and almost no current flows. So the circuit is more efficient and easier to design. MOSFETs can also handle much more current. These larger versions are through-hole type. We use them on test boards, but also PCBs. These smaller versions are surface mount type, and we use these in compact electronics. These multi-pin versions are just multiple MOSFETs combined together, but typically there is just one MOSFET per device. Try and build this circuit yourself. Take a 9-volt battery and connect it to one side of a lamp. Connect the other side to the drain pin of the MOSFET. Then connect the source to ground. Take another wire and connect this to the gate pin. Your circuit should look something like this. Notice that the lamp is off, but if we connect the gate wire to the 9-volt supply, it will activate the MOSFET and the lamp turns on. Current is flowing through the circuit like this. Now, if we disconnect the voltage to the gate pin, the lamp remains on, and that's because the MOSFET is now stuck. The gate terminal acts like a capacitor and it stores charge. If this charge has nowhere to go, then the MOSFET will remain activated. We can discharge the terminal by providing an exit to ground, which will deactivate the MOSFET. When the MOSFET is fully on, no current flows on the gate terminal. But when the MOSFET is changing from off to on, electrons rush into this terminal for a split second, and so there is a large inrush current flowing here. If you are using something like an Arduino to power the MOSFET, the current passing through could damage or destroy the board. So we need to add a resistor to the gate pin to limit the current. To discharge the MOSFET, we need a path to ground. Now, we can't use just a wire because too much current will flow. So we place a high value resistor here. When the Arduino energizes the gate pin, a small current will flow through the resistor, but the MOSFET gate pin receives the full voltage. When the pin is de-energized, the stored electrons can escape down to ground. If we place the resistor on the right-hand side, then we would create a voltage divider, and so less voltage will be provided to the MOSFET gate pin. For this reason, the left side is often preferred. For the next circuit, we again connect the 9-volt battery to the lamp, and then the lamp connects to the drain terminal. Then we connect the source to ground. Then we connect the battery to a resistor, and then to a potentiometer. We connect the end of the potentiometer to ground, and we connect the center terminal to the gate pin. The circuit should look something like this. The MOSFET will be activated, so the lamp turns on. The resistance is so high here that almost no current flows through the resistor. We just get a voltage. When we disconnect the power to the resistor, the MOSFET drains through the potentiometer. If we apply the voltage again, we can rotate the potentiometer to increase the resistance. That reduces the voltage available at the gate. As the gate voltage reduces, the MOSFET begins to deactivate, increasing the resistance between the drain and source. And so the lamp becomes dimmer and dimmer until the MOSFET completely deactivates and the current is blocked. So we can turn a circuit on and off, or we can vary the gate voltage to vary the resistance. We do also have a full tutorial on potentiometers, links down below. And you can also find links to buy one of our mugs and help support the channel.